Evaluating a function may involve substituting a number for f of x and then finding the x value or values associated with this number or y value. So let's say, for example, we had f of x is equal to 7. So we substitute f of x with 7. And that's equal to 2x plus 3. So what is the x for this case? This is the scenario we want to take a look at. So they're telling us the y value, and we're trying to find the x value associated with that y value for this particular function. Another example, let's say we had f of x is equal to 5, and that's equal to x squared plus 4x. What is the x value here? So in this case, the number 5 along the y-axis has two different x values associated with it. So how would we find both of these? This is the process we want to examine a bit closer. So let's actually do so by walking through an example together. Let's say we were given f of x is equal to x squared plus 4x. If f of x is equal to 5, what is the value of x? So in the question, it states the function f of x is equal to 5. So we want to replace f of x in our function with 5 and then work backwards to find x. So the first thing we want to do is we want to substitute 5 for f of x, giving us 5 is equal to x squared plus 4x. And now, since we have a quadratic, we want to move 5 to the right side and then factor the expression. So we'll subtract 5 from both sides, giving us 0 is equal to x squared plus 4x minus 5. And now the third step, we want to factor the polynomial. Since the coefficient of the quadratic term is 1, we can factor this if we can find factors of -5 that have a sum of +4. So we can get to -5 by multiplying 5 times -1. And the sum of these two numbers would be 5 minus 1, which is 4. So 5 and -1 are the numbers we are looking for. So this polynomial can be changed to x plus 5 and x minus 1. And now with the polynomial factored, we can solve for the x's. So we want to set each factor equal to 0 and then solve for x. So we'll start with x plus 5. We set that equal to 0. And to solve for x, we want to subtract 5 from both sides, showing us that x is equal to -5. And we want to set the second factor, x minus 1, equal to 0. And we solve for x by adding 1 to both sides, showing us x is equal to 1. So when this function is equal to 5, x can be equal to -5 or +1. And we can check this answer by plugging each number into f of x. So when we plug in -5 into f of x, we get -5 squared plus 4 times -5 is equal to 5. Remember in the original question it said f of x is equal to 5. So -5 squared is 25. 4 times -5 is -20. 25 minus 20 is equal to 5, giving us the true statement 5 is equal to 5, confirming that -5 is one of the values for x. And now we test the second number we got, +1, giving us 1 squared plus 4 times 1 is equal to 5. 1 squared is equal to 1. 4 times 1 is equal to 4. 1 plus 4 is equal to 5. Again, giving us a true statement, 5 is equal to 5, confirming that x is also equal to +1 when f of x is equal to 5. So that is how you go about solving for the x given a particular function. Let's now have you try a few practice questions. Given that f of x is equal to -4x plus 1, and g of x is equal to x squared minus 3x plus 4. Question number 1, If f of x is equal to 13, what is the value of x? Question number 2. If g of x is equal to 14, what is the value of x? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, substitute 13 for f of x. And step 2, solve for x. So we first want to subtract 1 from both sides, giving us 13 minus 1, which is 12, is equal to negative 4x. And now we want to get rid of this coefficient negative 4, so we divide both sides by negative 4, showing us x is equal to 12 divided by negative 4, which is negative 3. So we get x is equal to negative 3. And step 3, we can check the answer by plugging the number into f of x. So we want to plug in negative 3 here and see if the expression is equal to 13. When we do so, we get negative 4 times negative 3, which is positive 12, plus 1, which is 13, giving us the true statement 13 is equal to 13, confirming that x is equal to negative 3 when f of x is equal to 13. So that is the answer to question number 1. Let's now have a look at question number 2. We're given g of x is equal to x squared minus 3x plus 4. So step 1, substitute 14 for g of x. And since we have a quadratic and the variable appears twice, we want to create a trinomial that we can factor on this side. So we'll subtract 14 from both sides, giving us 0 is equal to x squared minus 3x, and 4 minus 14 is equal to negative 10. And now the third step, we want to factor the polynomial. So we want to find two factors of negative 10 that have a sum of negative 3. Negative 10 and 1 do not work, since their sum is equal to negative 9, and that does not equal negative 3. Negative 5 times 2 would give us negative 10, and their sum is equal to negative 5 plus 2, which is negative 3, and that's the number we're looking for. So our two factors will be x minus 5 and x plus 2. And now step 4, we want to set each factor equal to 0 and solve for x. So we'll start with x minus 5, and we'll add 5 to both sides, showing us x is equal to 5. And now for the second factor, x plus 2, we set that equal to 0. And now we want to subtract 2 from both sides, showing us x is equal to negative 2. So the function has a value of 14 when x is equal to negative 2 or positive 5. Now we can check these answers by plugging each number into g of x and confirming the result is 14. So if we plug in negative 2 for x, we get negative 2 squared, which is 4, minus 3 times negative 2, which is 6, plus 4. 4 plus 6 is 10. 10 plus 4 is 14, giving us the true statement 14 is equal to 14, confirming that negative 2 is one of the values for x when g of x equals 14. And we can check the second answer we got, positive 5, by plugging that in for x, giving us 5 squared, which is 25, minus 3 times 5, which is negative 15, plus 4. 25 minus 15 is equal to 10, and 10 plus 4 is equal to 14, giving us another true statement, 14 is equal to 14, confirming that x is equal to 5 when g of x is equal to 14.